Hello, and welcome back to the web series Developing SPECTER using Innoslate's digital thread. My name is Mallory Jones, and I'm a systems engineer here at Spec Innovations. In the previous video, I introduced myself, the Break the Ice Challenge, and previewed Innoslate's digital thread. In the second video for the Lunar Rovers web series, I will demonstrate the project initiation and programmatics used to plan and begin the Lunar Rover project to develop the Lunar Rover system. To initiate and program the Lunar Rover project, the documents, diagrams, and project management views in Innoslate were utilized throughout the following processes. In the Systems Engineering V model, these views take place throughout the ongoing parallel project management work. A Project Management Plan, or PMP, was created at the start of the Lunar Rover project in July of this past year, 2021. It was produced in order to define the project's scope, technical execution, schedule, and budget. In Innoslate, the Project Management Plan was created by going to Documents View, selecting the Project Management Plan document type, then choosing whether or not to use a provided template. For this PMP, I used the NASA Project Plan template so I could quickly get started with the provided outline automatically generated for me. The Lunar Rover System Boundary is a constrained scope that focuses only on the operations conducted on the surface of the Moon. The lunar lander's payload weight and dimension restrictions were adhered to when designing and landing the Lunar Rover. However, the lunar lander itself was not incorporated in the Lunar Rover prototype system. It is assumed this process of landing the rover on the Moon will occur outside the proposed system. When designing the Lunar Rover system, environmental conditions were considered and techniques were implemented to avoid any damage or subliminal loss during the rover's mission. Environmental conditions included extreme low temperatures at the excavation and delivery sites, reduced gravity, vacuum-like atmospheric pressure, and micro-lunar dust particles. The Statement of Work, or SOW, defines the technical execution of the Lunar Rover project. The tasks were broken down into 4 parts to produce the Lunar Rover prototype. These tasks included research and design, build, test, and demonstrate. A 5th task was also created to keep track of the Break the Ice Challenge deliverables that were to be met for Phase 1. Again, these were not submitted to the challenge since we entered late, but rather they were used as a guideline for designing and developing the Lunar Rover prototype. The tasks were created in an action diagram and ordered chronologically of how they were to be executed. Each task also had one or more input-output entities produced from its work. Those shaded green are final or technical documents, and those shaded blue are products of the Lunar Rover project. In Innoslate, the statement of work was created by going to Diagrams View and selecting the action diagram type. Once the parent action was created for the diagram, a parallel entity was dragged to the blank user interface to create various branches. Each action entity and its I/O entities were also added in the respective order of occurrence to represent the top-level tasks of the Lunar Rover project. They were each decomposed using a top-down process. The specific work of each task will be discussed during its respective web series video. From the SOW action diagram, a schedule was automatically generated by opening a timeline diagram or Gantt chart. The 2 diagrams offer different features which benefit a wide variety of work. After the timeline diagram was opened from the SOW action diagram, it was used throughout the Lunar Rover project to track the progress of the SOW tasks and subtasks, as well as to watch upcoming dates for project deadlines. Milestones were also added to the diagram to record the development progress of the Lunar Rover prototype. After the Gantt chart was opened from the SOW action diagram, dependency entities were created to connect the various SOW tasks and subtasks. These dependencies are represented by the black arrows in the chart, and they control the start and finish of tasks to create a more accurate critical path in the action diagram simulators. For example, the 3 subtasks define rover functionality, define constraints, and research rover components must all be finished before the subtask select prototype design can be started. This was because thorough research of the Lunar Rover prototype needed to be conducted before a proper design was able to be selected. Similar to the timeline diagram, the Gantt chart was also used throughout the Lunar Rover project to track the progress of the various tasks. A Kanban board could also be used to track the progress of the various tasks. However, for the Lunar Rover project, since we were actively keeping track of our tasks completion in the timeline diagram, the Kanban board chart type was used for other purposes. One of these purposes was to keep a live to-do list for bottom-level work that needed to be completed to support the various higher-level tasks. Each of the bottom-level tasks were also assigned to a team member for timely completion. To create this Kanban board, the project workflow template was used. This template automatically generated 4 columns and ordered them as shown. As each task was checked off the to-do list, it was moved from column to column. For example, the task created to produce a concept of operations started in the to-do column. Then once the assignee, myself, started the task, it was moved to the in progress column. After completing the ConOps document, it was moved to the in review column for a final pass of the product. The user dashboard calendar automatically populates start and due date attributes for Kanban boards, tasks, columns, and milestone entities in the current Innoslate database for the Lunar Rover project. The calendar focuses on timeframes and deadlines for various entities rather than progress like the timeline diagram and Gantt chart. Calendar charts can also be generated in Charts View using queries to filter and view specific project dates. Lastly, the work breakdown structure, or WBS, was automatically generated by opening a hierarchy chart from the SOW action diagram. Here, it is easy to view the decomposition of tasks in the Lunar Rover project. Up next in the web series, Developing SPECTER Using Innoslate's Digital Thread, is a video demonstrating cost and risk analysis. Thank you again for being here today, and I'll see you in the next video.